Today we are going to learn the unsupervised. Okay, so the unsupervised, till now we covered the supervised method, that is the regression and classification ensemble. Okay, these are the rows you are having and these are the columns. Okay, that is your any feature. Normally we take our data set, that bank data set, then these are the customer name 1 2 3, like that. Features could be customer ID. Okay, it's their income. Okay, their income, then their expenses. Okay, whether they are having credit card or not, yes or no. So like that, the features are there. On that basis, you are predicting that all these customers will take the loan or not, will pay the loan or not. Okay, so it's 0 1, then that means the first customer will not pay, second customer will pay, third customer will not pay, fourth will pay, fifth will pay, like that. It's called supervised. Supervised in the sense you are having a target column y with u. Okay, unsupervised, this column will not be there. Okay, you will be given with only the data set. So what are the use cases of that? So the use cases of unsupervised would be something called, you are given a data set. Okay, you are working with a automobile company. Okay, Mercedes. Okay, you are the data scientist there, where your manager or the marketing team wants you to build a model. The entire customers of the Mercedes, it can be on the basis of age. Okay, the segment would be there, because if you see the young guys, like who are in 30s to 45 years, okay, mostly they will go for the SUVs. Okay, normally the trend is the young guys will prefer, okay, this is you, SUVs. If you go with 45 to 50, may go for the sedans. Okay, so it can be different, the sedans. So it is like different guys can go for the different preference. Customers ranging between 30 to 40 or 45 years, they prefer SUVs. Then in the Facebook or any of the digital media, they can focus. Like if you see, if you are opening something in the Facebook, you are getting one type of ad. Okay, whereas the same Facebook, if your parents will open, they will get a different set of the ads. Why? Because Facebook is tracking everything. It's tracking your age, it's tracking your location, everything. So on the basis of age, okay, so the ad is categorized. Your marketing team wants you to find the cluster. Okay, so that for 30 to 45 years they will focus on giving more ads towards the SUVs. For 40 to 50 years they will go with the sedans. Okay, if 50 to 60 years, people would be having a lot of money because it's a retirement age. If they are going with very much luxuries, then they can focus on that. So that's called the unsupervised method. Okay, so in unsupervised, you can find the clusters, okay, within your data set. Use cases, as I told you, if you want to find something as a group or you want to categorize people in terms of the different groups, then it's required. You want to find the clusters, CLUSTERS. The main objective is here, okay, to find the clusters. What is hierarchical clustering? What is the linkage techniques? How it works? Okay, So we'll go through that one. Let me tell you, the k-means clustering is more powerful than the hierarchical clustering. Okay, so most of the parts you should be using the k-means clustering, but yeah, there is also another clustering, so we should know that. So for that reason, the hierarchical clustering we are going to learn. It is a part of unsupervised learning algorithm which is used for data clustering. Okay, and hierarchical clustering deals with data in the form of a tree or a well-defined hierarchy. Hierarchical clustering process involves dealing with two clusters at a time. The algorithm relies on a similarity, a distance matrix for computational distance, which two clusters merge and how to divide into clusters. Okay, hierarchical clustering. Okay, let's see. So the hierarchical clustering, okay, it assumes that first, this is the baseline. Okay, assumes that all the data points, whatever the data you have given, they are into the individual clusters. First, it assumes like this. Okay, all are individual clusters. Okay, so all your data, what you have given. Okay, so in the baseline, it assumes it will create a cluster for each of your data. Then what will happen? It will find the similarities between the clusters. Okay, in terms of the distance matrix, what is the nearest? Okay, nearest in the sense what's their behavior. So like that it will find, then it will see that okay, these clusters are similar, then it will form the bigger cluster over that. These two are similar, then these three are similar. In the second step, it will find, first it assumes that baseline, that all the models are individual cluster. Then it tries to add or merge different clusters based on different distances. Okay, and the next it finds this is a cluster, it's similar, then it finds one and put another one. Okay. Then it finds that these two clusters are similar, then this one, then finally this is the cluster. So the diagram will look like this. We call it as a dendrogram. Okay, D-E-N-D-O-G-R-A-M. Okay, G-R-A-M. We call it, this diagram is called dendrogram. So what it happens, if you see, it's the cluster 1. If you see that all the data points are clustered or to one group. Okay, because if you see this cluster contains all the data. Okay, if you see the level 2 or step 2, there are two clusters. If you see level 3, there are four clusters, this one, okay, this one and this one. Likewise, the last one is all data points are clustered. How to identify the number of clusters in your data, which is clearly a decision of a data scientist? Normally what we do, first you try to draw the dendrogram. Okay, so and now you try to cut it with a horizontal line. What's the maximum number vertical lines you are intersecting without touching the base? That's what the number of clusters. Suppose you see here, if I give you here a line, I am intersecting with two, okay, two vertical lines. So there are two clusters if you want to intersect here. Okay, but if you want to intersect here, now you see there are four lines. Okay, one this, this and this. That means there are 4 clusters. If you go down, then you are touching the baseline. Okay, here. So this is not a wise one. And the highest one is also not a wise one ever, because there is no point clustering. You are taking all your data into 2 clusters. So always try to find out the horizontal line, which is without touching the base, it goes through. That is the number of clusters in your data existing. Okay, it's a part of unsupervised algorithm, and hierarchical clustering deals with data in the form of a tree. A hierarchical clustering process involves dealing with 2 clusters at a time. The algorithm relies on a similarity or a distance matrix for the computational decision which 2 clusters merge and how to divide a cluster into 2. Here what we are doing, one method is we are merging the clusters based on their distance. Okay, so we are not dividing. Another way is that assume that all the data points into the single cluster. Okay, now try to divide it. Okay, same thing what we have done it, but it's that's the top down, it's the bottom up. Here the data point, here the data point. Okay, here the data point. So like this it will the same thing, but it's totally opposite. The best one for the hierarchical clustering is this method. It takes all the data points as the individual clusters, then tries to merge it based on the distance. Okay, so there are 2 types of hierarchical clustering. I told you here, one is the bottom up, one is the top down. This is the bottom up, this is from the top we are going down. These differ in a way of developing a hierarchy, the agglomerative clustering and decisive clustering. This is called agglomerative. Okay, agglo, and this is called the decisive. But most of the part going with the agglomerative. The agglomerative generates a bottom-up hierarchy. Okay, approach. It takes all points as individual clusters, then merges them on each iteration 2 at a time. Okay, if you see, it takes all as an individual cluster, then merges 2 or 3. It's not required that only 2. It can be more than 2, more than 3, like this also. The decisive follows a top-down approach for the hierarchy generation. It starts by assuming that entire dataset is one cluster. Okay, here it's a one cluster 1, then it's the cluster 3 clusters, then it assumes that there are 5 clusters. Okay, so decisive follows a approach hierarchy generation. It starts by assuming the entire dataset is one cluster and divides it until all points become individual cluster. Okay, so what is the distance? That matters a lot. Assume that it's a set of data points or the clusters. These are the number of rows 1, 2, 3 in the bank data set. Okay, this is given. So what it assumes that all these are individual clusters. That means if you put it here, it assumes that this one, all these are individual clusters at base. That is 1, 2, 3, 4. These are the number of records of different customers. We assume that all individual customers are different clusters. Now it tries to merge the customers. Okay, it finds that 1 and 2's behavior are almost same, then it merges into one cluster. 3 and 4 almost same, then it merges into another cluster. Okay, like this. 1, 2, 3, 4. Then it starts merging. Then after that it starts merging again. Okay, like this. The distance of 2 points, okay, between the clusters it takes. Another method is the complete linkage. Okay, the distance between 2 clusters is defined as the longest distance. Single linkage, shortest distance. If you see the image here, shortest distance between two cluster points is the longest distance, is the complete linkage. Average linkage, the distance points, okay. Each point will be computed a distance to the other point and the average will be taken. The distance between two clusters is defined as the average distance between each point in one cluster to every point in the other cluster. If you see the three images, the first one is the shortest, okay. The distance between points, wherever is the less, you are taking that distance and you are plotting the hierarchy. The complete linkage, you are taking the highest distance and plotting the hierarchy. Average distance or average linkage, the distance between two clusters, the average distance, each point in one cluster to every point in the other cluster. You are taking all the distances and you are doing average. Okay, this method, no need to, it's a hyperparameter, you can give it or it's directly there. We will see the hyperparameter for this model, then you will understand completely. Single linkage, complete linkage, average. Single is the shortest distance, complete is longest, and average. So what are the steps for this agglomerative clustering? I have already explained. Define each point as a cluster. Calculate the initial proximity matrix. Okay, basically for you, no need to do anything. The package will do the work for you, but you should understand that how the package means how the model is generated. That's the idea behind this, the theory means the class, that you should know what is going behind. Calculate the initial proximity matrix. Proximity is nothing but a distance metric. Okay, merge two clusters which are at the closest or similar based on the metric. This merging can be done with the single linkage, a complete linkage, average linkage. Revise the proximity metric and repeat the step until a single cluster remains. Okay, until a single cluster. This is the single cluster. Okay, cluster 1. This is the single cluster. Until you reach this point, do the same thing. Okay, first you take all the data points individual cluster, check the distance between them, merge them. Now in the second step you identified 4 clusters, then check the distance between them, merge them. Like this merging happens till you reach this point. The package does the work for you. Okay, so what's the pros and cons? Here we do not need to specify the number of clusters required for algorithm. The dendrogram produced is a very useful in understanding the data, and hierarchical clustering is easy implement, whereas the disadvantage getting back to the previous step is not possible. Once the data is generated, then you have to go through this one only. If there is a change in the cluster, suppose you say that you want 3 clusters, previously you checked, now it's 5 clusters. It's all depends on 3, 5, 7, whatever the cluster you want. By seeing this diagram only, the model cannot create it for you. The time complexity for the clustering is very long. Okay, the time it takes a long as compared to the k-means clustering, and for a large data set it can be difficult to determine the correct number of cluster. Okay, what's the problem with the large data set? Because suppose you are given 10,000 data points. Okay, a data set with 10,000 rows, it assumes that all these 10,000 the basis are individual clusters. Okay, it's a huge, right? I am only talking about 10 files here or 10 data points in the data set. Where it is 10,000, it's a huge. Then it will group. Okay, then it will group like this, like this. Okay, so it's a very time consuming process. This is the agglomerative. Okay, bottom up. From the bottom you assume that all clusters are individual, and then you try to find the cutting line to identify the number of cluster. If you see, the dendrogram is a type of tree diagram showing hierarchical relationship between different sets of the data. It's showing a hierarchical relationship First, all are individual clusters, then they group it. It contains the memory of hierarchical clustering algorithm. So just by looking at dendrogram, you can tell how many cluster is formed. So if you see, it's a single cluster L2. In L3, there are 3 clusters. Okay. The hierarchical clustering, it also helps you to find the number of clusters. It's all depends on you, as I told you, that whether you want 3 cluster, 5 cluster, it all depends on you. But the method we follow, the cutting line, okay, without touching the base of the clusters. So data set will go through the 200 customers. Once we complete our k-means clustering, then at once we'll go through the k-means as well as the hierarchical clustering.